Good afternoon to all students. Today I discuss about that Leibniz theorem and means that is the finding that derivative of the function of Leibniz theorem means there some formula is there. See here Leibniz theorem means Leibniz theorem for the finding the antiderivative of the product of the two functions means the product rule is there. I explain here only. See here the statement is there, that is a very important means that is the one question asked in your annual exam. See here statement, let u and v be any two function of x means u and v is the two function of the x, then nth derivative differentiation of nth derivative of u into v. What is the differentiation nth derivative u means? That is equal to u into that differentiation of means nth derivative of v plus nc1 into differentiation of u into dn minus 1 into v plus nc2 means here nc1 over then nc2 nc2 then d square of u into n differentiation of n minus 2 into v. 1 minute, once again see here u first function as it is, then differentiation of second plus nc1 means that is the first one, nc1 the value is n, okay, then differentiation of u. Here differentiation of v is what? Next differentiation of u into that is the previous term. Here d to the power of n of v is there. Here d to the power of n minus 1 of v. Here d n minus 2 of v. Means that previous term. Here one is there nc1, nc2, then so on, then ncn. Means that is the differentiation of u. Finally this one. In other way, un to the power of n means that is the un, uv of m is equal to u into, see here, u into differentiation of v. dn to the power of v, how to write that one means? That is the vn plus n into nc1 value is n. I write here n u1, this one. I am saying this one. n u1 v to the power of n minus 1 plus that is the nc2 means we write the simplification, that is nc2 how to write means n into n minus 1 divided by 2 factorial into u2 v of n minus 2 plus then nc3. nc3 means we take n minus 1 n minus 2 divided by 3 factorial into u3, then v into n minus 3 plus so on un into v. Remember this one? This is the important. When you don't forget this formula, once again I tell this one, u into that vn. 1 minute, see here. Here u is there. Next step u1. Next step u2. The next one u3. You observe this one. After that here vn is there. Then previous term v of n minus 1, v of n minus 2, then v of n minus 3, then so on, that is v. Okay. After that, here take the here n factorial. Here n is there. Here n this is the n2 means nc2 means then n minus 1 by 2. Then nc3. nc3 means n minus 1 n minus 2 divided by 3 factorial. Okay, this is the formula there. This is the important. Okay, see here some notes is there. I read this one. Choosing the function of the first and or second one, very important, means in your question asking two function is there, means one algebraic, one trigonometric given, means which one you are choosing, that is the important. Means choosing the function has a first or a second is very important. A function v can be taken as a second function, second function only when its the antiderivative is known. Okay, you remember this one? Means that is the first which one function you are choosing, that remember that one. Next go to a second one. Second note is a algebraic polynomial function like x or ax plus b or x square or ax plus b to the power of q. means etc. should be taken as a first function. Remember this one? A algebraic polynomial of a function like x, ax plus b or x square, okay, that be taken in a first function. This is because after the sum stage means derivative of the such function vanished. Means suppose we take the x square, means x square differentiation is 2x, 2x differentiation 2. Then after that the differentiation that is 0. Okay, such function vanish and hence the above process is terminated. Okay, next third step is third note is applying the Leibniz theorem. We can understood the following as means here three steps is there. You see this one. See here. This is the first step. Keep the first. First one I say note that one. This is also same. Keep first function as it is a right nth derivative of second function. Means keep first function is as it is. Means suppose we take two functions that is u and v, means we take first one is as it is, u as it is, then the nth derivative of second one, second function, means which is in the bracket. See here, see here. U first function is there. You put as it is u, then the vn means nth derivative of second function. It is the first step. Next second step, take plus sign and appropriate coefficient, means nc1 means that is the nc1 value is that n. That is the second step. Next go to a third step. Observe the previous term, means that is the previous term means nc1. No, sorry. That is, we suppose we take n. See here, observe the previous term. U into vn. Then this previous term is un into v of n minus 1. Observe the previous term and the differentiate the first. First means that is the u function. U and the replace n by n minus 1 within a second bracket. Means right here n into that u1 and v of n minus 1. Here given u of that u into vn is there. This previous term is n into u1 into p of n minus 1. Next fourth one, step 4 is proceed the same way, do taking the proper means proper coefficient, that is nc2, nc3, means that is the next term. nc1 is first term, then nc2, then nc3, that is the second and third step. So on. After that, the step 5 is there. What is the step 5? In each stage, we write the term. Look at the previous stage, means we take this one. Differentiate first bracket and replace n by n minus 1 in the second bracket. Remember this one? Replace the, means differentiate first bracket, means for first bracket you first bracket to differentiate, then replacing n by n minus 1 to second bracket. Means this is the first bracket and this is the second bracket. Okay. See here, you only remember this node. Okay, in your example, first example, see here, find the nth derivative of x square into sin square 4x is there. Okay, see here, this is your question. First you write y is equal to this x square into sin square 4x is, okay. First you know that one, that is the x square as it is. What is the sin 2 theta? What is sin 2? That formula is there, trigonometry formula. That is the sin 2 theta is equal to 1 minus cos 2 theta divided by 2 is there. Okay, I write here that sin 2 theta. I simplify this one. 1 minus cos 2 into 4 is, that is the 8. Means sin square 4x is there. That's why 2 into 4 is 8x divided by 2. Then that is equal to 1 by 2. That take common. This y and 1 by 2. Then you multiply this inside. X square into 1 is that x square. Then minus x square into cos 8x. Okay. After that, this is the y term. After that, we take yn. Okay. yn equal to 1 by 2 constant as it is, I write. Then after that, the nth derivative of that x square, I write separately. Nth derivative of x square minus then nth derivative of the second term. It is x square into cos 8x. Okay, then simplify this one 1 by 2 as it is. Then differentiated of x square means x square differentiation is 2x. Then 2x differentiation is 2. Then 2 differentiation is that 0. Means you write directly d to the power of n x square. Means that value is 0 minus then minus d to the power of n into x square. See here, here two function is there. X square one function, cos 8x another function. Okay, in Leibniz theorem statement we say that one. First you take the x square. First the function is x square considering. After that cos 8x is second function. Okay. Then d to the power of n into x square into cos 8x. Means this is the first function and this one is the second function. Next apply the Leibniz theorem. That is the yn equal to minus 1 by 2. Y means where minus. This minus take outside. Minus 1 by 2 into. See here, first function as it is. First function means that is the x square. Okay, x square is there as it is. First function as it is. Then differentiation of second means cos 8x is there. Means a to the power of n into cos of n pi by 2 plus 8x. Already we did in previous example. This is cos 8x. How to write that one means a to the power of n into cos of n pi by 2 plus 8x. Okay, plus means bracket close plus. Next step is NC1 is there. NC1 means alright, that is the NC1 value is N. Okay. This is the N into. Next one, x square differentiation. Means u differentiation. X square means x square differentiation is that 2x then into next second function. Second function that is the cos the previous term. A to the power of n minus 1 into cos of n minus 1 pi means replacing n by n minus 1. That is the next step. Okay. In your note, I tell that one replacing the second term where n is there, n minus I write n minus 1. Means here 8n is there. I write here second step that is the 8 of n minus 1 into cos of n minus 1 pi divided by 2 plus 8x. Okay, this is second one. Next third step it plus that NC2. NC2 means I write that one n into n minus 1 divided by 2 factorial into next step here. X square differentiation is 2x, then 2x differentiation is 2. Okay, 2 into that a to the power next step. Here a to the power of n I take. Next previous term is a to the power of n minus 1. Next previous term is a to the power of n minus 2 into cos of n minus 2 pi divided by 2 plus 8x plus next plus 0. How to write 0 means here right here. That is the final answer. The fourth term is 0 because the differentiation of first bracket is previous stage. Means first bracket is 0. That's why. Okay. Means 0 into anything is 0. That's why this is the final answer. You only applying that Leibniz theorem. See here. First, even you are given that find the nth derivative of x square into sin square 4x means you take the first simplification. After that, nth derivative that is the yn. After that, you applying the Leibniz theorem. Okay. When in your exam, when you will doing when you solve this question, first you write the formula also. Each example you write the formula. That time you remember this one. Okay. Next second exam is here, that is also same, but here log is there. Means if y is equal to your question is if y is equal to log x divided by x, then prove that this is important. Okay, in your exam, ask this one. Y is equal to log x divided by x. Prove that. Then yn 1 minute. See here. Y is equal to log x divided by x. Prove that yn equal to minus 1 to the power of n into n factorial divided by x to the power of n plus 1 log x minus 1 minus 1 by 2 minus 1 by 3 so on minus 1 by n. Okay, see here. What is your question? Y is equal to log x divided by x is there. Okay, prove that. Okay, you know that one log x differentiation 1 by x is there. First you take y is equal to. What is the log x divided by 1 by x is there? I write here separately log x into 1 by x. Okay, it is same. Log x into 1 by x. By applying the Leibniz theorem, differentiate n terms. You remember this one? Yn equal to. Here nth derivative yn equal to then nth derivative of log x divided by log x into 1 by x. Okay. After that, this log x is first function. 1 by x is second function. I already tell this one. This is the u and this is the v. Applying Leibniz theorem. First, you remember this one that you already wired that one. What is Leibniz theorem formula means? First, you take u into differentiation of v. See here, first function log x as it is, then nth derivative of 1 by x plus nc1 into differentiation of that first function, that is the log x, into then the previous term d to the power of n minus 1 by v. V means that is 1 by x plus nc2 into then d square. D square means that is next step, that is the log x, into d to the power of n minus 2 into that 1 by x plus so on d to the power of n log x into that phi. Phi means 1 by x. Okay. Remember this one? First you write the formula. After that you write this example. Okay. Each example you write the formula. After that you solve this one. You don't write there directly. Okay. See here, once again I tell it one, log x, first function as it is. Log x means that is the first function as it is. Then nth derivative of 1 by x. In previous example, we did this one. Nth derivative of 1 by x means minus 1 to the power of n into n factorial divided by x to the power of n plus 1 plus nc1. What is the nc1 value? N. I write here n. nc1 value is n. Then differentiation of log x. Log x differentiation is 1 by x. I write here 1 by x. Next, then differentiation of n minus 1 into 1 by x. Okay, here d to the power of n 1 by x is there. Then previous term d to the power of n minus 1 into 1 by x means minus 1 to the power of n minus 1 into n minus 1 factorial divided by x to the power of n. Means that is the previous term. N replacing n by n minus 1. Okay. Next plus then nc2. nc2 means n into n minus 1 divided by 2 into minus next step is that log x is there. Differentiation of d square of log x, this one. Log x differentiation is, sorry, x differentiation is 1 by x. X square means that is the 1 minus 1 by x square. Here d square is there. Okay, that's why minus 1 by x square. Differentiation. Next, then d to the power of n minus 2 into 1 by x is there. I write here minus 1 to the power of n minus 2 into n minus 2 factorial divided by x to the power of n minus 1. Means here x to the power of n plus 1. Then here x to the power of n. Then here x to the power of n minus 1. That previous term. Okay. Means n plus 1 previous term is xn. Then extend x to the power of n. Then x to the power of n previous term is x to the power of n minus 1. This next x to the power of n minus 2, next previous term. Okay. Then plus so on. The finally write here d to the power of n dn log x into 1 by x is there. Then I write here minus 1 to the power of n minus 1 into n minus 1 factorial divided by x to the power of n into 1 by x. That is the phi. Means d to the power of n log x value is this one. After that 1 by x as it is. Finally you write here yn equal to minus 1 to the power of n into n factorial divided by x to the power of n plus 1. Okay, take this one. This one write first. After that log x minus next this term. Minus 1 to the power of n into n factorial divided by x plus 1. Sorry, x to the power of n plus 1 minus minus 1 to the power of n into n factorial divided by 2x to the power of this 2. 2x to the power of n plus 1 minus so on minus 1 to the power of n into n minus 1 factorial divided by n into x to the power of n plus 1. This is your final answer. See here, this is the therefore k into k minus 1 factorial equal to k. Okay, I write here n into n minus 1 factorial means that is n. That's why I write here that is the minus. We'll take common minus 1 to the power of n into n factorial. Here minus 1 to the power of n into n factorial is there. Here minus 1 to the power of n into n factorial is there. That's why I take minus 1 to the power of n into n factorial divided by x to the power of n plus 1 as it is. Then remaining term is that is the log x is there minus that 1 is there. Totally take it is outside means that is the only remaining is minus 1 minus that is the 1 by 2. Here the 1 by 2. Here 2 is there. 1 minus 1 by 2, then so on minus 1 by n. Okay, this is the important is there. You practice in home. This is second example. Okay, y is equal to log x divided by x. This is the second example. This is five mark question. Remember this one. And when you are once again I am telling when you are doing this problem means you first you write the Leibniz theorem formula. Means that 2 marks for that formula. Okay. Next question is there. Next one see here. This is next question is important means in your annual exam ask this one pre into last exam means your senior batch ask this one. If y is equal to tan inverse of x, then prove that 1 plus x square y2 plus 2x y1 is equal to 0 and hence show that means that is the 1 minute. See here, your question is y is equal to tan inverse of x is there. Y is equal to tan inverse of x. See here, what is your proof means? Prove that this one. You prove this one. After that, show that this one. Okay. First, you take the solution that is the y is equal to tan inverse of x. You know that one. What is the tan inverse of formula is there? Tan inverse of x means 1 divided by 1 plus x square. Okay. First, you differentiate 1. This is the equation 1. Okay. After that, differentiate 1 with respect to f means that y is there. Y differentiation is y1 equal to. What is the tan inverse of x? 1 divided by 1 plus x square. Okay. After that, differentiate. Next, again differentiate this one. First, you take this one. That is the 1 plus x square. Take this side means that is the 1 plus x square into y1 is equal to 1. Okay. Next, differentiate. Differentiating again. Means you again differentiate this one. Again differentiate means that is the second term differentiate. Next 1 plus x square. Okay, 1 plus x square as it is. Then differentiation of second term. Second term means that is the y1. Y1 differentiation is y2. Okay, next plus then second function as it is. Means here u into v formula. You apply u into v formula. U as it is. Then differentiation of u. Sorry, differentiation of v. Then v as it is. Differentiation of u. You know that one. First function as it is. 1 plus x square as it is. Then differentiation of second function y1 is there. Y1 differentiation of y2 plus then second function as it is. The y1 is there. Y1 as it is. Then differentiation of 1. 1 means that is 0. X square differentiation is 2x. That is equal to 0. Okay, that is given here product rule means u into v formula. Okay, and next again. Next continuation is there. This is very important. After that, you apply the Leibniz theorem. See here 1 plus x square that is that right return this type 1 plus x square y2 plus 2x y1 is equal to 0. Okay. This is one result. Okay. First next you apply this one. No differentiate n term. This is the d to the power of n. This I write this one 1 plus x square y2 plus 2 constant is there. They take outside then d to the n to the power of x y1 is equal to 0. Okay, no applying the Leibniz theorem means you apply Leibniz theorem. I write here. This is the formula. Okay. This is the first function. This is the second function. Then 1 plus x square as it is, u as it is, then differentiation of second one. Second one means that is the y2 is there, then y2, y to the power of is y n plus 2 plus then n, that is the nc1 value is n, then 2 into then x, sorry, d to the power of n, xy1 is there. That's why it is applying ev here. That is the 2x into y n plus 1 plus nc1, sorry, n into n minus 1 divided by 2 into that 2, this one, that's 2 into yn plus that last term is 0. Okay, here right here y in y nth derivative of y2 is equal to y of n plus 2 and nth derivative of y1 equal to y of n plus 1. It is right here. Okay, this is the y of n plus 2, then y of n plus 1. Then plus, that is last term, that plus 2 of x, y of n plus 1 plus n of that 2x difference is that 1, then yn plus 0 is equal to 0. Okay, you write this one, or is there, you see here, means your proof is asking which one you are asking, you write that much. Okay, that is next final answer is 1 plus x square, that is the y of n plus 2 plus 2nx, 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 y of n plus 1 plus n square minus n, take this one, n into n is n square minus that n into 1 is n, this one, n square minus n yn plus 2x y n plus 1 plus 2n of y is equal to 0. Okay, or class worker. Next, or you write that is the 1 plus x square into y to the power of n plus 2 plus 2n plus 1 x y of n plus 1 next plus n square. This simplification only. Okay, n of y equal to 0. Means here 3 result is there. Which one asking in your annual exam? You write that one. Okay. In your example, you ask this one. Okay. Means 1 plus x square y n plus 2 plus 2 n plus 1 x y n plus 1 plus n into n plus 1 y n is equal to 0. This is very important. Remember this one and you practice this one. When you are applying, you write here a Leibniz theorem formula. Don't write directly. You write here formula. Okay. Next example, see here. This is also very important. In your textbook, three example is there. This is the first one example, and second one is also very important. Means one example fixed in your annual exam. See here. This is the first one. Okay, this is the second one. Sixth example is second. Means see here, if y is equal to e to the power of tan inverse of x, then prove that this one. You try this one. This is very easy, and only I explain this one. First, you are given y is equal to e to the power of tan inverse of x. Okay, then prove that this one. First, you take y1. Means differentiation of this one. Y differentiation is y1 equal to e to the power of tan x. E to the power of x differentiation is e to the power of x only. That's why I write here e to the power of tan inverse of x into. Next, tan inverse of x differentiation is 1 divided by 1 plus x square. You know that one. I write here e to the power of tan inverse of x as it is. Then tan inverse of differentiation is 1 divided by 1 plus x square. Next simplification. 1 plus x square, the numerator is there, come to this side means that is multiplication. 1 plus x square y1 equal to e to the power of tan inverse of x. Okay. E to the power of tan inverse of x means you know that one, that what is the e to the power of tan inverse of x means that is the value is y. That's why this e to the power of tan inverse of x means I write here y. Means 1 plus x square into y1 is equal to that y. Okay, after that you y go to this side means it is the plus is there, come to this side my minus. That's why 1 plus x square into y1 as it is minus y is equal to 0. Next differentiate n times. N time differentiate means next apply the Leibniz theorem. D to the power of n 1 plus x square y1. Here this is the u, this is the v. You apply the Leibniz theorem minus then the n derivative of y is equal to 0. After that you apply this one, then simplify. It is 3 lines. Okay, this is for your homework. Okay, you do this one. This is also very important. Remember this one, Leibniz theorem, one fixed question is in your exam, final exam. In last previous example, sorry, exam asked this question only. Okay, in previous question, last year asked this question. Example 5. Okay, means one fixed question asked in annual exam. Remember this one. Okay, next class I continue this one. Next question is there. This is also same. You do this one. If y is equal to e to the power of minus x square, then prove that y of n plus 1 plus 2xyn plus 2n of y of n minus 1 is equal to 0. Okay, this is only 3 steps is there. First you take y is equal to e to the power of minus x square. First take solution. After that y1. You find y differentiate means that y differentiation is y1 equal to e to the power of as it is. E to the power of minus x square as it is. Then minus x square differentiation is minus 2x. Okay. You write this one means it is the y. Y means e to the power of minus x square is there. I write e to the power of minus x square means I write here y into minus 2x. Okay. After that simplify this one. Y1 differentiation of y is this one. Y1 that minus 2xy come to this side means that is the plus 2xy equal to 0. Again differentiate n times. Differentiate n means that is the differentiation of y1 plus 2 constant take outside, then d to the power of that xy equal to 0. Here 2 function is there. Apply the Leibniz theorem. Here the second term is x and y is there. That's why you apply here. X is the first function, y is the second function. Okay. You try this one. Okay, thank you for all. Next tomorrow class I will discuss. Another one example is there. I will discuss tomorrow. Okay, this one I discuss tomorrow. Only 2 example you do this one. Okay. Example number 8 and example number 6. You do this one. Okay, I already explained. When once again I am telling, when you are doing this problem means you write the Leibniz theorem formula. Okay, thank you for all.